Jayanth, I'm Dinanath Prasad, going to discuss one topic on Power System 1 subject, the topic of transmission and distributions of electrical power system. So in this topic, I will cover first a structure of power system. What is a structure of power system? So in this structure of power system, basically we having a structured in three way. First one is called generation system. Second one is called transmission system, and we divide it. A third we call distribution system. So basically, briefly, we having classified our structure of the power system as three way. First one is generation, second one is transmission, and third one is distribution, which is shown in this diagram, or this is symbolically representations by some color like red. Red color we represent it to the generation side, blue color represent for the transmission, and the green color is represent for the distribution side. If we're talking about the voltage level, we always generate power at low voltage on the range of 11 kV, or less than that. Means idea is that we generate power at low voltage side, and on the second side, if we talk about transmission line or transmission side structure, they having always we transmit the power at higher voltage on the range of 765 kV for the very large user consumers. Means in very big industries, they required large amount of voltage, so we will provide them with the help of a step up transformer. We step up the voltage on the range of 765 kV, and they will fit them to this load. And other load for the transmission system is classified as primary transmission and secondary transmission. So in the secondary transmission, we transmit the power on the range of 138 kV range. Now come to the distribution side. So we having the distribution side is also classified as two way, that is primary distributions and the secondary distributions. So according to the voltage level, we already classified. For the higher voltage side, they will call primary distribution, and for the secondary distributions, like on the range of, according to depend upon the user, they may be single phase user load or three phase user load. For the single phase user load, we will transmit the voltage of around 220 volt or 230 volt, and for the three phase user load, we distribute the voltage or power on the range of 415 volt or 420 volt. So this is the brief structure of the power system. Now coming about the sources of the electric energy. So if we say broadly classifications of electrical energy, we have been classified as two way. First one is renewable energy, another one is non-renewable energy. On another term, we are called renewable energy as a non-conventional energy source, and the non-renewable energy sources are called as conventional energy source. The basic difference between renewable energy source and non-renewable energy source is that we can renew the power, which source of energy will be free of cost, that are categorized, we can use again and again. We can not they cannot affect our environment, they cannot generate any greenhouse gases to the environment. They all are classified or taken care on the side of renewable energy. And another part, that is non-renewable energy source or conventional energy source, like the coal, oil, gas, natural gas, Nuclear power plant, they are classified as a non-renewable energy sources or conventional energy sources. They are once they use, they are deplete. They are not able to reuse again and again, and these kind of sources can affect their environment. They can generate greenhouse gases in the environment. So this is the basic classifications of the between the renewable energy sources and the non-renewable energy sources, and these are the some sources here are called as classified as a renewable energy and non-renewable energy. Like if we talk about renewable energy sources, like wind is one of the non-renewable energy sources. This is geothermal, this is tidal, solar, wind, biomass. These are the some source of energy which is categorized in a renewable energy sources or non-conventional energy sources. If we talk about non-renewable energy sources or conventional energy sources, we take care for the like coal, oil, this is a nuclear power plant, and natural gas. These are the some examples of the non-renewable energy sources. So if we talk about what are their installed capacity, as we know, the installed capacity are changes yearly by yearly. So this is the data according to Wikipedia. This is the data of according to 31st January 2021. What are their contribution, what are their percentage? You can see the coal percentage is around 53.1%. So we can see if you compare with the previous data, the coal percentage are deplete or reduce day by day, and non renewable energy sources contributions are increased day by day. Because of that, because of they create pollution, they can affect our ecosystem, and the reason being that the coals are depleted day by day. So this is the contributions of other sources like coal. This is contributions for the large hydropower plant. A small hydropower plant is taken as 1.3%. We having solar power plant as a renewable energy sources. They having contributions is around 38 gigawatt, or percentage wise it is around 10.3%. Wind power plant is around 10.3%. The percentage of gas is around 6.6%. The biomass is one of the another renewable energy sources. Their percentage is around 2.7%. Nuclear energy based power plant, this is non-renewable energy source. Their percentage is 1.8%. Diesel, this is again conventional energy sources. Their percentage is around 0.1%. So this data is changing day by day. So this is the latest data, or you can say this is the data according to 31st January 2021. So this is the major source, and what are how they generate, where they generate. So some of the listing of the sources of energy, like natural gases. So natural gases we can combine alone, and this is the part of furnace boiler system to generate the steam. Another one is coal. This is used for coal based thermal power plant for generating the steam, and further it is used for producing the electricity. Now this is come to petroleum. We can burn and produce the combustion gases or steam power plant, turbine. Nuclear power plant, this is the one of the sources. We can produce power by the process of nuclear fission process, and further it can use for generate the electricity. This is hydropower plant. Basically hydropower plant are classified as a small hydropower and large hydropower plant. This is for a bit talk about large hydropower plant from dam and other setup for power turbine that is used for flowing water. This is wind. This is one of the growing source of renewable energy source. Through that we can turbine, which is capture energy from the wind and conversion to the electricity. Now come to biomass. This is derived from the plant, animal waste, and material that is one directly used to other fuel of power turbines. That is another one is solar. This is used to electricity by with the help of sun. Sun is captured in a photovoltaic cell to produce the steam and other purposes. Geothermal, this is another example of renewable energy sources. Through geothermal, we can produce the heat within the earth and harness the heating water into the system with the help of power turbine. So these are the some listing of listed examples of the energy sources through we can produce the electricity, or we can do any other further work. Moving on, now come to layout of hydroelectric power plant. First of all, before we going into to introduce about the hydroelectric power plant, I will say this is we talk simply hydroelectric power plant, how they categorized. Either we take hydroelectric power plant in a as a renewable energy sources, or hydroelectric power plant as a non-renewable energy sources. So this is one of the classification of hydroelectric power plant. If we take it is a renewable or non-renewable, this is simply based upon whose system disturbed our ecosystem or not. So those hydropower plant who destroy our ecosystem, they affect the system, that kind of hydroelectric power plant, or large kind of hydroelectric power plant where we require a reservoir, we make a dam, we can make a special arrangement. That kind of arrangement we make on that classifications we are calling as large hydropower plant. And in case of a small hydropower plant, we cannot need, as the water comes, a turbine rotated, electricity produces. So that not need the special arrangement, that cannot affect our ecosystem. They are classified as a small hydropower plant, as a renewable energy sources. So this is the basic layout of hydroelectric power plant. Means we have discussed here for the large hydroelectric power plant. So first of all, if we going to layout of the hydroelectric power plant, we will discuss here some of the component of hydroelectric power plant, like reservoir. Second one is dam. This is gate. This is penstock, surge tank, inlet valve, turbine, electric generator, draft tube. So these are the some components, brief components, or you can say this is the part of the hydroelectric power plant. I will discuss here one by one what is it. First one is reservoir. Basically, a reservoir is to capture large amount of water, and this will be made artificially make to store the water behind the dam. So second one is dam. So dam is established after the reservoir. This is completely done by the civil work to basically not pass all water or controlling of water. We make a stubborn obstacle for the water, and we will put after the reservoir. That is the function of dam. And if we come to third part, that is the gate. This is first component, second component is dam, third component is gate. So the function of gate is to just a flow of water. This is just like a tab. When we want to enter the water into this pipe or not, that is based upon our requirement. So according to our requirement, we open the gate or we close the gate. Another this surge tank, this is fourth part. I will discuss later. First of all, I will discuss here fifth part, that is penstock. This is simple. Penstock is a pipe. This is generally made of steel. Through that, water flow, water regulations can be made. Inlet valve. If we say this is the sixth part of the hydroelectric power plant. So inlet valve, how much water we want to enter into the turbine, that will be decided by the inlet valve. Now come to turbine. This is 7 part. The function of turbine is to just as the flow of water come, they will strike water into the turbine. Turbine rotates and this turbine is directly coupled to the electrical generator. They will convert mechanical power as a water into the electrical power further. And this is 7 part. Let's suppose this is 8 part. Now this is 9 part, that is the draft tube. The function of draft tube, just the unused water is come out with the some arrangement, and the water will be arranged come out from this device that is known as draft tube. So this is the last part, and we having not discussed here the fourth one part. What is surge tank? The function of surge tank, as you can see, there is a two gate or two flow of water arrangement. One is gate, that is number 3, and the number 6. So this is the 2 tab which is installed inside in between them. We having a surge tank, that the function of surge tank is to basically compensate the flow of water, like in this penstock. Sometime the water regulations will increase, means pressure inside the penstock will increase. Sometimes the vacuums will be created in the penstock too. So we make a surge tank which is placed with the some height to reduce the pressure, that is technically we called as hammering. And if sometimes there will be vacuum will be created in the pipe, or you can say penstock. So to controlling the water, to maintain the vacuum, to control the vacuum and the pressure hammering, we have solved this problem with the help of surge tank. Further, I will discuss this component one by one. Like this is dam and reservoir. So this dam is constructed in a large river or hilly areas to ensure sufficient water store at some height. The dam form a large reservoir which is behind it. The height of the water level, which is called the waterhead, is in the reservoir, which is determined how much potential energy is stored into it. Now the control gate, this is the function like just open the tab when we require the water to flow water into the penstock, or we not want to flow water into the penstock. That will be controlling with the help of control gate. Another one is penstock. So penstock is basically made up of a huge steel pipe which is used to carry water from the reservoir to the turbine, which is potential energy of the water is converted into kinetic energy that is flow drawn through the penstock, which is flow through the gravity. Another one is water turbine. So basically water turbine we classified as a 2 types. One is known as impulse turbine and another one is known as reaction turbine. So what are the basic difference between impulse turbine and reaction turbine? They are classified according to their head and according to their discharge, means according to our requirement which kind of water turbine be placed in a large hydropower plant. So you can see impulse turbine, this is used for large head, and for the reaction turbine it is used for low and medium head. And for the generator, so generator is directly coupled to the water turbine. As the turbine rotate, the shaft of the turbine is directly connected to the generator. They will use to flow or convert mechanical energy into the electrical energy. This is the function of generator, basic part. This is the surge tank, as I said earlier. the surge tank is placed in between the control gate, means this water gate and this water gate. We have seen, I hope this is number 3 and number 6. In between them, a tank will be placed. Basically, when suddenly in our requirement, sometime we close this gate, but some water is still present in this pipe, or sometimes we close this number gate number 6, so some water will be here. So sometimes in the pipe, or you can say in the penstock, water hammering, means the pressure inside the penstock will increase, or sometime there will be vacuum will be created. So this surge tank will be installed between this 3 and 6 number, and this surge tank, through surge tank some water will be flow outside, and the according to requirement the water will be flow inside the tube. So this is the main function, to control the hammering and the vacuum. This is that why we make surge tank. Now we will discuss here the types of hydroelectric power plant. So there is a various way to classify or types of the hydroelectric power plant. One of the classification, that is conventional plant, pump storage plant, run of river. What are the difference? Conventional plants are the basic. This is used for just potential energy from dammed water. The energy extracted depending upon the volume and height of the water. The difference between the height of the water level in the reservoir and the water outflow is called water head. This is the simple working of the conventional kind of hydroelectric power plant. What is pump storage power plant? This is a special kind of power plant, is designed for the peak load. As you can see in the previous diagram, as the water flow come to the ground on the peak time, and peak time or peak for the peak load, or in the light load conditions, like in the night hours, we flow lower. We make a special arrangement from like this is the height, this is the dam, this is the pipe, this is the turbine. After turbine, the water will be used. So we can use again from flow of water from this level to this level. We can feed this water again to this dam, or you can reservoir, to fulfill the sudden peak. With this pump storage plant can be fulfilled. Run of river plant. What is run of river plant? One kind of power plant where the water will be a storage, like in case of large hydropower plant. Another kind of power plant, in a small hydropower plant, we not need to store the water in one place. So as the water comes, the turbine will be rotated, and consequently the electricity will be made. But in case you can see in the run of river power plant, we didn't need any kind of construction. We can not required reservoir. You can say reservoir is absent in this case, as the river is available for the generation, and due to the absence of reservoir, the oversupply of the water is passed unused. So this is the basic classifications of conventional, pump storage, and run of river power plant. Now come to advantages and disadvantages of hydroelectric power plant. So we can see there is no fuel is required, as the potential energy stored water is used for electricity generation. This hydroelectric power plant are some kind of neat and clean source of energy, because they cannot generate any harmful gases into the environment. Their very small running charges. Basically, we know the water availability is we can available in a free of cost. It require less maintenance, and they having longer life, that means more than 50 years. And another, it can use for several other purposes such as irrigation, farming, and many more. These are the some advantages. The life will be very high, and we not require maintenance regularly. These are the major advantages of hydroelectric power plant. If we come out to disadvantages, one major disadvantages is their capital cost. The initial capital cost of hydroelectric power plant is very high, so we need initial investment on that for the running of power plant. After all, once they run or will commissions this hydroelectric power plant, we can use for the longer line. Another major disadvantage is high cost of transmission, because they are very away from the consumer, they are very away from the load center. So where we generate the electricity from that place to any places, any populated place, we can transmit the power. So the transmission equipment we need, the transmission cost will be increased. This is because they are available in a very hilly areas, or very very large places from the populated area. So these are the disadvantages of the hydroelectric power plant. For that, thank you.